Good evening. Can I have a quick mic check in the comments if I'm audible? Can you give a thumbs up or okay or yes, anything? Yes, splendid. You don't know how excited we are because if you have been with us, the last time we left the session on a cliffhanger. There was so much that was remaining to be discussed, yet the the content that we had planned was in a series. So, hello everyone, and a warm welcome to all of you. And welcome back to Lamperos Dow Live, first of all. It is great to see you all again here. And, well, of course, some of you might be familiar, and others are new faces. So, for the new ones, I'll just give a very quick introduction. Lampros DAO is a collective, community of sorts of builders. We are researchers and analysts that come together, and all of our focus is on a single thing. We focus on turning on-chain activity into clear and data-driven insights, and we also believe that things like governance, especially in decentralized systems, and ecosystem behaviors in decentralized systems, these are not matters that can be merely discussed as a fireside chat. They should be measured, they should be analyzed and understood thoroughly before we put them out as perspectives. So today is the second part of what we had started as something new. It was a series that was something different that we had been doing. So over the past few months, you must have seen us discussing dashboards, discussing data threads, maybe even protocol insights. All of those were focused on what already had happened on chain. Now, but before any of that data has existed, so there is a much deeper story that goes on. Data cannot just exist to be. There has to be an underlying robust technology that makes it possible for transactions, for actions, for different you know uh, behaviors to happen on chain. And robust systems like Ethereum make that possible. And that was the layer that we had discussed in the last session as well. And we will be discussing this time as well as a sequel to our last session, which was very packed with insights. So if you are new and if you do not know, Ethereum just shipped Fusaka. It is one of its most important upgrades in years, and more importantly, the second one within a span of half a year, or I'd say 5 months. Now, but to uh, make sense of what Fusaka changes and why it matters, we took a step back in the last session. We understood the foundations and we understood the problems that Ethereum in general had set out to solve. Now, moving on, we have come to this session today. I know that last time, we kind of left on a cliffhanger, but we did so because this session today was going to be entirely only focused on Fusaka itself. So last time, after we discussed that and explored that why Ethereum existed, how it's structured after the merge, there were many analogies that our technical expert gave to us, and we discussed forks, we discussed EIPs, and a lot other things. Plus, we also discussed some other last upgrades. Throughout that session, For today, we have arrived at Fusaka. So, this session for today is about understanding what Fusaka actually changes. Now, what those changes are and why those changes actually matter, and how would they compound into Ethereum's long-term scaling strategy. So, we have with us Akash. Akash, would you like to introduce yourself? Hello,
Hello
everyone.
everyone, I'm Akash from the developer team at Lempros DAO. Nice to meet you again.
It is our pleasure to have you on board as well. So, now that we are getting into it, there are a lot of EIPs that towards the end of the last session that we saw. So Fusaka, from a far away view, can look a bit overwhelming. There is a long list of EIPs that there is. Of course, it is spread across execution and consensus, but uh, even the name tells us a story. If I may, correct me if I'm wrong, Fulu is a star and it represents upgrades to the consensus layer, and Osaka is the city that hosted DevCon 5th. It represents upgrades to the execution layer. So, just like the name, Fusaka itself is a fusion. It changes across layers, all are coordinated into one upgrade. So now, please understand that although we might be getting deep into the technical details, the goal of today's session is not to memorize EIP numbers. It is to understand the shape of the upgrade, what the headliners are, what problems they solve, and what new doors they open to us. So, with that perspective, take out your notes, take out your pens, start noting, ask questions, share perspectives, and let us have an open mind and see how the shape is changing. So, with that framing, let us start with the part everyone has been hearing about the most. So, uh, I think if you have consumed any Fusaka related content, this has been the buzzword. It is peer das. So, let's see a short video, shall we? So, if you have been around on Ethereum, and you can go out and check this video on Ethereum itself. So, PIDAS is kind of becoming a buzzword with the Fusaka upgrade in position, and I guess you can check it out by yourself. So, Akash, over to you. Can you walk us through why this is kind of becoming the star of the show? What is Peer Das, and why is it that it is coming up repeatedly in coverage?
Okay, so before we jump into what this change has introduced, first let's see what the current bottlenecks are, what the current problem with the blobs is. Last time we said blobs were introduced, L2 scaling was much cheaper, but there is still a problem. So let's go back to our that public lane analogy. We introduced a blob lane in our road of traffic on the highway. So it works great. Like much more larger data can be moved through the blob lane, but there is a limit. So for like traffic control and verification, Let's say there are cameras and road sensors. They are the nodes of Ethereum. So each node has to verify every single bus that is going on the blob lane. So like every block submitted to the Ethereum L1 needs to be verified by each and every block. So each and every block needs to download all the blocks which are submitted. So like if we added too many blocks, the nodes would get overwhelmed by the sheer amount of data they had to verify. First, they have to download and then verify. So the network gets congested and the computation also gets congested. So this is the limit, the bottleneck of the current block implementation. So the solution is this peer DAS. Peer DAS stand for data availability sampling. So we are using a like much older concept of sampling in this data availability. So instead of having every node having to check the entire bus, uh, imagine each node just glance at one specific part of the bus. So there will be four different nodes for, or maybe eight different x number of nodes verifying the tires. Yes, the tires are there, they are in good condition, and they are means they are valid tires. Same way, there would be different nodes validating each and every part of the bus. So they all say it looks good, and we can mathematically certain that the whole bus is good and well enough. So our whole blob is verified. So this is data availability sampling. It allows the network to process vastly more data without forcing every single node to upgrade its internet connection. So it's like BitTorrent logic applied to blockchain validation. So now I'll say some part of the blob. So how much part? So that is decided that each node would download 1/8 of the blob data. So the capacity for layer 2s by an order of magnitude 8 times has been increased. So now this has been increased without any upgrade to the hardware requirements. The stakers, the validator nodes, those who are running, they don't need to upgrade their hardware, their internet connection. The existing one can handle much 8 times more L2 data.
I like how it is BitTorrent logic applied to blockchain. Not only blockchain, but blockchain validation to be more specific. So let us say that the previous upgrades gave us the blob lane, while PRDAS is the one that removes the bandwidth bottleneck inside that lane. Can we say that? Yes. Okay. So instead of every node that is downloading every blob, nodes sample small parts. Yes. Okay. And
Like
like
it works with eraser coding. So like that works in our QR and every day-to-day implementations. So if you need to verify the whole blob, you don't need to check all the 8 nodes having the data. You just need 50% of the data and you can verify it. It is like a magic of cryptography and mathematics in the back. No need to go there. And the thing we need to understand is why we could have just asked the validators to upgrade their hardware requirements. Why we went through this means the struggle, not struggle, the hard work of upgrade, implementing this in a such a way. So, like you need to understand that Ethereum is an open network. Anyone should be able to join as a validator on it. It is a proof of stake. So the stake is the um, important part in the validation process, not the hardware requirement. If hardware was to be a means we need to keep hardware as a requirement, then we would have means stayed on the proof of work mechanism. So we need nodes which can be run on a vast number of machines without much higher hardware specifications.
correct. So now, I mean, this entire upgrade that we are seeing here does not stop here, of course, but I mean, this is paired with another powerful thing. It is kind of quiet, but it is a critical change. So, could you walk us through this one? What is this? Is it a gas fee increase or gas limit increase? What is it? So, is what is the one that we are seeing right here on the screen right now?
No, this one is different. Like the gas limit increase is a different EIP 7935. I think this is the 7918. So let me explain this one. So there was also a concept of uh, block base fee along with that gas. So L2 is submitting a block to the layer 1. It would pay for the execution cost, like the gas used in the verification of the block data. Along with it, it will also pay for a base block base fee. So like it like let's take our blob lane. So like if a bus operator is running a bus on the lane, the operator needs to have a ticket. Uh, if it doesn't, the ticket itself is that base fee. So it is like a verification process that this blob is being submitted to the L1. So like how would I explain it? So this base block base fee is also a price signal of the congestion. So when we see higher gas prices on Ethereum L1, it can be due to the regular L1 users submitting more demanding transactions, or it could be due to congestion from L2 block submission. So we won't know which is which without looking much into the data. The second price signal would have been this block base fee. So if the block base fee is high and the gas fee on Ethereum is also high, we know that L2 are pushing much more data, and we need to update that network, update some part of the network. So, but there was a weird economic quirk here that L2s were paying gas just to verify the ticket they had. Uh, Means they had the ticket. So sometimes it would happen that this gas fee cost would overshadow the block based fee. And so the block based fee would return to zero, like not zero, it is one way, like smallest unit of payment in Ethereum. So this base block based fee EIP fixes that by bounding the block based fee for to the execution cost. So if the execution cost goes up, the block base fee would also go up. And those would need to pay much more amount of Ethereum when submitting blocks. So one would ask that L2's cost have increased. How is that helpful? So like let, take it from the other perspective. Before L2s were using L1 block means L1 storage, uh, dirt cheap money. Like one way was the price, but now this EIP ensures that L2s pay a fair share for the computational load they are putting on the network.
Interesting, all of these dynamics are that you know smallest of things have to be taken into consideration, and upgrades and EIPs were made for that. Now, before we move ahead, there was another EIP that we mentioned, which was the EIP 7935. If you want to shed some light on it before we move ahead, which is the gas limit, gas cap, which is increased per block. So, like,
Since Spectra, we have been increasing the gas limit per block. So that last time I explained also like not we need to put a cap on computational load the network can handle. So that is put through this gas. So in Fusaka, this gas limit was increased to 60 million from the previous 45 million, which was just increased some months ago. And before that, it was 30 million since Spectra upgrade. So, like these two updates, the gas limit cap to 60 million and the peer dash, the economics of Ethereum change fundamentally. So, like for a long time, Ethereum was dominated by high value transactions. So, DeFi swaps, lending, NFT sales. It was not for smaller amount transactions. Like if a transaction cost $5, you move $500 with it, not $5 with $5. So you won't buy coffee with Ethereum. You won't do regular transactions like your taxi rides on Ethereum. But with Fusaka, this cost floor has collapsed. So like platforms like Farcaster or Lens can now scale to millions daily post. Like interacting on Farcaster, posting a like or short text comment becomes negligible in cost because it lives in abandoned drop space which we are getting. On-chain gaming also won't be like turn-based strategies in which you do a one move per day because one move is costing $5. Now assets can be minted and traded in background without bankrupting the player, so players can make multiple moves. So fast-paced games can be introduced.
And
And
in
in
India,
India
we
we
have
have
UPI.
UPI.
So
So everyone asks like, can Web3 handle UPI? No, not at the moment. But like changes like these two, the gas limit peer does, we will soon reach developers can build a payment app where transaction fee doesn't eat the lunch money you are spending. So this upgrade doesn't make the existing things cheaper. It also opens paths to much impossible things like which were earlier not feasible. You couldn't think of UPI on Ethereum, but with these changes further down the lane, with more changes you could. It is a major step in that direction.
I see now what is happening and why people are with all of the new avenues that are opening up. Why people are comparing it to their things which were might be considered menial or things were not much ever seen in scope up till now. So I think this kind of high throughput infrastructure is changing behavior as well. So now if we go ahead, so we discussed this one EIP 7918.
so yeah, I didn't mention the
The
graph
graph
here.
here.
So
So,
like
like on December 2nd, you can see the block fee, total block fee paid on in paid to Ethereum for submitting the blocks were less than less than 1 million. But as soon as the Fusaka went live, it went up, shot up to 80 million, I think, approx. So 80 times more, we can say. So like now L2s are paying Ethereum what Ethereum is owed to compute and verify their data. So this jump is good enough for it, means good thing for Ethereum.
Yes, understood. So if we move on, this is this was a post, a status post on uh, Twitter by Etherscan themselves that the blob count is shooting up, and they've also highlighted the first block at the new 15 blob limit. So, I mean, what would you say about this? What is this EIP and what is happening right here?
okay,
The number has gone up, but the important thing is the method it was increased. So we have a new EIP affecting this. It is called BPO, block parameter only fork. So well, we have widened our blob lanes. More blobs can run through them, but we still have to traffic control. Like we cannot push each block with maximum block capacity, congesting the network or eventually crashing it. So this EIP decouples the traffic limits from the road construction. So road construction are our Fusaka upgrades, our vector upgrades, the annual upgrades which would get. And we can, with this much scaling we have mentioned before, you cannot wait for a full year to increase some parameter like blocks per block. So this we have decoupled in this fork. So you can now tweak the number of blocks allowed per block via simple configuration update in the clients. You don't need to wait for a major update. It can be done whenever the need whenever the need occurs. So allows React to it allows Ethereum to react to demand in real time. If the lane is kind of empty, the traffic is low, we don't need to change it. Keep it as it is. If it is getting full, we are seeing for a longer period of time it is staying full, then we can submit a change to all the validators. Consensus would be reached, and they can increase the BPO. So that is what has happened here. Earlier, you can see that blocks were being submitted. That has been increased to 15 in this upgrade, and it won't stop here. If you go to the website blocks.money, so it will show the current block base fee, and in the top right, you can see the next update of the blobs. So yes, we are seeing the block base fee, and on the top right corner, you can see on January 7th of 2026, in 3 weeks' time, the blob number is again going to be increased to 21. Currently, it is 15. It again we will be increasing it. So, um, like this is a step-by-step procedure to reach our current network capabilities step by step. And again, the block base fee is updated. It changes per block now. Earlier, it was like constant one way or some 2 3 ways. Now it's dynamic.
That is in fact quite interesting. So I'll be putting in the link to this website as well. You can check this real time, just like the real time update that we are looking at with block parameter only forks. And I mean, truly, what an amazing upgrade that we have here. So now we know that Ethereum can now respond to demand in real time and not an annual upgrade cadence. So in terms of blobs, we'll take a little pause here and let us look at the beginning of something other than this, which is also quite broad. So now we come to this one, which is, if you see the EIP number 7951. What is this? What is this block? A biometric on chain authorization, and what does it do?
This is the one EIP your non-crypto friends will care about. So whenever we onboard some new users to Web3, everyone is scared of the seed phrases, the private keys, the password of the wallets, and everything. So that is because until now, Ethereum didn't natively speak the language of like security enclave chips, what we have in our iPhone and Androids, the biometrics, the fingerprint or the face scan, those things. So if a wallet wanted to uh, incorporate those security features into them, like Face ID or Touch ID directly, they had to go through multiple gymnastic kind of mathematical and cryptographic functions to achieve that. So it's like our phone Touch ID speaks a different language, and Ethereum EVM needs a different uh, language interpretation. So Fusaka upgrade and this EIP, it's a pre-compile for this. So pre-compiler like a kind of in library functions in the EVM So it means that Ethereum now natively speaks and understands your phone's security chip. So the result is you can sign transactions with your Face ID. So no need seed phrases to memorize, no complex hardware wallets for average user. Just how you use your normal banking apps with Touch IDs, your WhatsApp Messenger with Face ID. Your face is your key, and the chain verifies it directly. So the barrier to entry, what most new users face, that that can and will be removed with this EIP.
Not surprising, but this is a big deal. So as you said, there is no extra exercising around those wallet passcodes, or there are no phrases here. So now Ethereum speaks the language of your phone's secure hardware. Is that what you mean?
Yes.
Yes.
So
So
earlier,
earlier, like it was like rapping, no, like a translator. Your phone speaks some dialect of English. I speak some dialect of Hindi. Those two cannot understand. You need a translator in between. And now the security is as good as the translator. So if translator loses some meaning in the translation, it is a loss of data, which is much important in this security aspect. And now both are compatible, both are on the same language. So there is no loss of data. It is as much as secure as your phone is. And again, there is no biometrics you have on your body. You don't need to memorize. So that hassle is gone.
Truly, Ethereum is becoming this one is a big one for all the non-crypto users. It will now come. It has, of course, taken a leap, and I believe it will go on coming closer to, the people who are not very familiar with the ecosystem of cryptocurrency or Web3 in general. So now, moving on, there is another tweet, which is by Ali TSLM on Twitter. We have given all the credentials, the credits of all these tweets, all these statuses. They go to the respective people who have tweeted them. So this one talks that there is a after the upgrade there was a very small gap, and then there was a massive behavioral change immediately after it. So what is this? What is this sort of absence or sort of gap that is there after the upgrade, and then what is then again of shooting up of sorts, or what is this change of behavior post the upgrade then that we are observing here?
Okay, so like this is due to this EIP 7825. It puts cap on transaction gas. So like now each transaction has a limit of nearly 16.6 million gas. So earlier there was no. So you could submit a transaction which would consume 10 million, 20 million gas, and it would execute. But with this change, there is a cap now. So you can't have like here it was possible for hackers to submit large gas transactions and take up the whole block, making the network congested, spiking up the gas fee. So it was like one giant truck taking up the entire highway lane, which we are referencing. So now this EIP allows more means to handle more traffic while preventing worst case scenarios that could stall the network. So like and with this the gas cap on per block also increased. So you could say like at max, at worst case, there would be only 6 transactions in a block, near to 5 or 6 transactions, and at best there would be hundreds of them in the block. So it is like a simple equation. We have the gas limit has increased, so we would have more block space. So you could say like much larger and congesting transaction would be submitted. So we put on a safer limit along with that gas limit increase. So we have more block space with safer limits, and it leads to reduced congestion. And if the network never gets congested, the gas fee is stable and lower for everyone.
Wow, I mean, quite quite a managing move there. So there is more block space and there are guardrails to secure it. And this, I think, also means that when you said that what makes the gas price stable, it means that there is no single entity or transaction that can monopolize the network in the time being. So that's not restriction at all. That is merely, I mean, really excellent congestion control right there. So,
And for the gap, like this, it
This
mentions.
is the gap. So as you know, this EIP was in works for months. So every major transaction, on Etherscan, they are called gas guzzlers. So like transactions which consume a large number of gas and are done frequently in a day. So they are the major gas consumers on Ethereum network. So these gas guzzlers knew that this EIP was coming. So and they knew they were submitting on the brink of this limit. So as soon as that upgrade went, they settled down their activity for some quite some time to verify like those transactions which were earlier working could still work. And once they tried means ran simulations and uh, did test runs, they got confident and they started their regular activity again. Some of them functions need would have been updated, like if they were using 18 million gas, so they would have optimized those functions in some way or another to be in the limit, so the transaction would never fail. That's why there is a gap. The EIP was introduced, everyone got kind of defensive or protective, tested their functions and contracts, and then started their activity again.
I mean, I think it is a game of testing and then going ahead, of course, with every upgrade. Uh, but we are we have a lot many EIPs to go through again. Now we come to this one, which is, I mean, this one explains the gap again by Jarrod Watts. He's an amazing one. I mean, we have referenced several of his tweets throughout our presentation today. But yeah, I think what you explained is
Yes.
explained here. So, I mean, do check out these users and do support them as well, because anyone who, you know, does this for the community, it is always good if they get recognized and they get acknowledged for their work. So, shout outs to Gerard Watts on Twitter. The gap after the Fusaka upgrade, particularly pertaining to EIP number 7825, is explained here. We now move on to the deterministic proposer look ahead. It is a user experience oriented change. I mean, before we again go deep into technical stuff, this is a user experience oriented change. But I mean, with all these three words, deterministic, proposer, look ahead, it is kind of jargon and it sounds abstract. Assume that I am someone who does not understand it. So, can you explain what it is, what it solves, and what is it all about?
So
So
it
it
sounds
sounds
tech.
technical, but it's also simple anxiety. So whenever you submit a transaction on Ethereum L1 specifically, you get a question in your mind that did my transaction go through? And you have to wait till the block finalizes, that you know yes, your transaction was successful or reverted. So this is what this EIP is. By letting the network know for sure who the next block proposer is. Wallets can give you a pre-confirmations, so you don't have to wait 12 seconds to feel safe, or it's less than 12 seconds. Like you get a thumbs up almost instantly because we know exactly who is in next in line to write that block. So that's why it's deterministic. Like earlier, until and unless the block was finalized and submitted on chain, you won't know who the proposer was. With this change, uh, the mechanic is same. It is still selected with randomly based on their weightage of the stakes and everything. Just it is announced 2 epochs earlier. So you know for this block number who the proposer is, and with this you get a much improved UX for fast-paced environments like trading, lending, or arbitrage. You don't need to wait 12 seconds to see the result. You get instantly thumbs up. Interesting. So
With this done, there is another interesting thing that I came across on Twitter. So now there is this guy who said this, that the ETH bull posting is so strong that it makes me nervous. Anyways, the EIP 7939 parentheses for CLZ is coming upcoming Fusaka hard fork. Speed up compute and math heavy functions by up to 63 times. I mean, wow. If is this about making the entire network durable, or are these some flashy changes? Because I mean, claiming a 63 times increase is actually wild. So please walk us through what is going on over here and what are these other EIPs that are also at play here.
so it is not a single EIP. There are 4 of them, and all those 4 are EVM optimizations. So it is like upgrading the engine of your car. So this is the nerd stuff. Like if I explain the mathematics and cryptography and the architecture of EVM, you won't understand. So I will cover them in brief. The 4 are uh, first is leading zeros opcode, like counting leading zeros opcode. So it optimizes the 56-bit math that Ethereum runs on. And there are 2 for ModX. There is a opcode in EVM called ModX. Uh, and these 2 EIPs update that function. So not basically update the function. They set a limit on the input, how much big of an number you can put into that function, and it also has increased that gas cost. From earlier it was 200 gas for one call of that function. Now it is set to 500 gas cost. So it is done for better pricing accuracy. And the last one is recursive length prefix. So Ethereum doesn't restrict the size of a block, but the network layer, the P2P layer, can't propagate a block greater than 10 MB. So this RLP execution block size is that setting that limit on the block. So where 8 MB is given for the execution layer data and 2 MB buffer is kept for the consensus layer overhead. So overall, that limit of 10 MB is never reached. So these 4 upgrades are like reduce the risk of future over sized block attacks or much accurate pricing of functions which are used in cryptography. So ModX is mostly used in cryptography. And now, if there was like inaccurate gas pricing of functions, so attackers can spam the network with those cheap heavy math problems and congest the network. So these upgrades take those things like niche things attackers can exploit. So, like one would ask, like these should be designed at first before implementation. Like, why was the network vulnerable to these kind of attacks till now? So these kind of changes are what you introduce after you have experienced your car running. So like you cannot oversee these kind of changes or limits you need to set. Once you run your car, you get first-hand experience how it feels. Then you can tune the engine. So these 4 are like tuning the engine to make engine run much smoother and safe, and it gives road for much advanced computations we will need in the future. So Vitalik has been promoting privacy on Ethereum. ZK proofs are coming with those, and those are very heavy math problems which are need to be solved on chain. So these upgrades are to ensure that safety to be ready for those changes when they arrive.
Nice. So, I mean, these kind of changes, I think they can, these are the ones that one our team makes after a system has worked or survived through real world stress. Like you said, it is kind of an engine tuning. It is not some work on the outer body that is pre-made. This is after one goes through what they go through. So, I think guys, so far, look at the amount of EIPs that we've covered. So we have 7 and 4, 11 EIPs that we have covered. Two EIPs remain to be covered. Uh, what are they about? I think one is about history expiry, and the other one is about update of some method. Can you shed some light on that?
So 7910, it is an update to a JSON RPC method. So how Ethereum nodes work, how your wallet or your front end interacts with those contracts through the node is through this JSON RPC method. So there are multiple different methods available, like uh, send transaction, get balance, those kind of functions. Along with this EIP introduces a new method, ETH config. It is not meant for the usage of network. It is meant for better interaction between clients. So this ETH config will have data like what current version they are running, the node is running on, what EIPs they are following, what is the last update timestamp and everything. So those kind of things will be in this method. So it is for better client interactions, nothing else, not for normal users. Then comes the history expansion you mentioned. So for years, the Ethereum nodes have been holding every single byte of history. Each transaction that has went through those nodes, they have stored it. So it's like keeping your every grocery receipt you have ever had in your life in your attic. So eventually, the floor would collapse with the weight. So this EIP tells the nodes that you only need to keep the recent history. Recent history means post merge after September 2022 on your fast access self. The old stuff can be discarded or it can be assigned to the full archival nodes, which are much slower and heavy storages and much expensive too. The faster, cheaper storage, you need the data for after the merge. So with this EIP, like I think 530 GB of archival data can be removed. So like 530 GB is quite a sum for storage. And each node, each like there are thousands of validator nodes across the globe. So 500 into those thousand, it is quite a large amount of data. So the nodes can drop this. So it reduces the hard drive space needed to run a node. Smaller nodes like more hardware, normal hardware can run it, more home stakers can run it, more decentralization. So that sums it.
So, I mean, now that we've gone through each EIPs, we have two more things to show. One is this one, which is a user testimonial that the first time the user had said that Etherscan was not ready for Fusaka, and then Etherscan very kindly replies that fixed it, and now we're ready. So this one is a user testimonial. Would you want to share any perspective on this one?
Yes, you
You
can
can
see
see
like
like generally dollar is indicated with two decimal places for the cents. So the gas value went down so much that even cents could not cover it on an L1. This is not an L2. We have seen this in Arbitrum, RBScan, and everything. So this is L1 Etherscan. So now Ethereum has fixed it with 5 decimal places. So now if we want to represent the value in dollar for a gas, how much gas price was paid, you need 5 decimal places. That's like a thousand of a cent.
Interesting. And the second testimonial that we have is from, of course, one of the most important component of the entire ecosystem, which is the developers. So this one comes from Austin Griffith, and there is DeFi Beats who has replied to Austin Griffith's status. So what are they saying?
So yes, like this Fusaka upgrade has brought much for developers. For all the developers out there, you have new tools to build seamless wallets with. You have a stable, scalable foundation for your L2 apps now. You have a network that adapts to the demand without waiting for annual hard forks. So, like the world computer which we have envisioned for these two episodes from past two episodes is no longer a prototype. With Fusaka, it is becoming a global supercomputer that fits in your pocket and scales to the world. And it is on the shoulders of developers, us developers, that we need to bring out the full potential of this world computer. The core team, the core developers of Ethereum are doing their work quite good. The other developers, which will build on those, will build on this network, need to step up now.
I mean, you being a Web3 developer yourself, is there some kind of a, I don't know, pressure might be a wrong word, but let's say that pressure in a good sense that you feel that now that Ethereum's developers are doing such a good job, do you feel some kind of push on yourself that how do you feel about all of this?
I would say motivated. Like uh, I am quite new, but there are much developers in for quite a few years, and they would have seen the difference. Like the since the introduction of like switch to proof of stake and then introduction of L2s, the scaling we have the scaling before and the scaling which we can achieve now are like magnitudes of thousands or I would say millions. So the opportunities are quite vast. Like it is becoming a more level playground similar to Web 2. You don't face much problems now. You have much better interfaces, much better DevX experience. We say UX similar to UX, so much better DevX experience. And yes, we are getting new tools to play with. Like here we have got biometrics to play with now. So before I mentioned social media, your WhatsApp has security with your Touch ID. Same way your wallet can have, your Farcaster can have the same. So it is a combination of these EIPs. Now, like they have laid the bricks, we can take it any combination and build something wonderful.
Correct. I mean, yeah, that's, I think, so that kind of brings us to a wrap for today. We have gone through each and every EIP that there was, and I mean, there is actually in the latest upgrade. So, I mean, if I think there is one takeaway from today, then it is this that Fusaka is not your, I mean, mere optimization to Ethereum. It is changing what is feasible. Like you said, that the world computer is not a prototype any longer. It is something which has become very scalable, very accessible, and at the same time, what the target was resilient and robust. So, thank you, Akash, for walking us through with this clarity and, as usual, your analogies. So, I mean, what we saw with Fusaka is not a single breakthrough, but a coordinated step forward. Scaling through blobs, better economics for rollups, stronger guardrails for the network. There are meaningful improvements to user and node experiences. So, this is essentially Ethereum continuing to mature as an infrastructure and not chasing speed or superiority for its own sake, but expanding capacity without compromising decentralization. Now, Fusaka also makes the direction very, very clear. Ethereum is not trying to do everything on the base layer. Instead, it is also making layer 2s cheaper. It is making them faster and easier for developers like us to build on. While while it has kept the core network stable, secure, as well as widely accessible, this design choice is intentional, and I think that is what allows the ecosystem to scale sustainably. So once again, Akash, thank you so much. And to you, our dear audience members, a very, very heartfelt note of thanks to all of you. You keep joining us and you keep motivating us. For today, we are going to be wrapping up, but feel free to reach out to us in the comments on our post anywhere at any of our handle, whether it is Twitter, it is YouTube, or on our website. Reach out to us if there is any sort of feedback, anything that you would like to see next, or any sort of critique as well, or it is a simple doubt that you want us to answer for you. Reach out to us. We'll ensure that we get back to you with the correct answer, with the correct data, because that is what we do. And well, until then, we hope to see you again very, very soon again in the next session. We come back live every Tuesday at 15 hours UTC. Hope to catch you all again very soon. It has been a pleasure, as always, talking to you. Thank you for joining Lampros DAO Live. Have a great day ahead.